The virtual keyword in C# allows you to achieve polymorphism. Once you've applied the virtual keyword to a member, it becomes what we call a virtual member, and then you can override that member in a derived class, essentially change the behavior, become polymorphic. Members are non-virtual by default, so you have to selectively apply the virtual keyword in areas where you want derived classes to be able to change the behavior of what you've provided. For instance, in this animal class, there is a virtual method called performTrick, and inside of here could be some code that is an implementation of something that all animals can do. Then when someone else creates a dog class, they inherit that behavior from animal, but they're going to override what happens in performTrick and perform their own sort of dog trick. Now inside of here you also have the option of calling into the base class implementation and invoking that behavior too. Sometimes that is something that you need to do with some frameworks. The important concept to understand here is that virtual members are dispatched based on the runtime type, not the type of the variable. Let me give you an example by using our sample project. Let's say that when a circle draws itself, I want to change the behavior just ever so subtly, and I want to turn the circle red. So what I'm going to do is I'm going to say element.fill equals a new solid color brush that is going to be using the color red. That'll change the color of the element. Now we actually have to do the drawing still, so I'm going to call into the base class and still take advantage of the code that's inside of there. So with this code in place, let's flip back into our main window and remember that we're creating a square and a circle and 100 more shapes, and run this program and see how much red appears on the screen. Well, this is sort of interesting. I only see one red dot out of about 100. Now why would that be? Well, remember that I said that virtual members are dispatched based on the type of the object, and that means that regular methods are dispatched based on the type of the variable. So down here we're creating 100 circles and we're passing them to a draw shape method that is invoking the draw method, but it's invoking that draw method on a variable that is typed as shape. And that means that this line of code is always going to invoke the draw method that is in that base shape class. The only place where we are actually invoking draw and setting the color to be red is when we are invoking draw on a variable that is typed as circle. So S2, when we do S2.draw, that's going to invoke the draw that uses a red brush and tells the base to put it on the screen. If we want true polymorphism, first let's go down here to the base class and mark draw as virtual. I'm going to do a build and you'll notice that we get a warning here. What I haven't done on this in this derived class is I haven't told the C# compiler that this draw implementation should override what's in the base class. Instead, what I've effectively done is create a second implementation of the draw method. And if we run this program again, what we're going to see is the same behavior. There's only one red dot. And the reason is that in C# terms, this draw method is hiding that base class draw method that is virtual, and this is still not a virtual method. If I don't want to hide that method, if I really want to change the behavior of what's going to happen with circles, I'm going to use the override keyword. And now what happens is anytime that the draw is invoked on a shape that is of type circle, regardless of how we've typed the variable, at runtime, the CLR is going to look and see that the implementation of draw is being overridden in this derived class, in this derived circle class, and so it's always going to invoke this method. So let's run the program one more time, and now we see lots of red circles. So just to recap, before we introduced the virtual keyword and used the override keyword, shape.draw was always going to do the same thing. It was always going to invoke the draw method on that base shape class. But now that this is virtual and we override it in a derived class, we're effectively changing the behavior of what happens during .draw.